Okay, today we're going to use sum and difference identities to evaluate trigonometric functions. The reason for this is to find the exact values of trig functions of angles that are less common. So, these are the sum and difference identities. And what we want to do is find the exact value of each trigonometric expression. Now let's look at this first example, and then we'll look at the identities. So what we want to do is we want to find the cosine of 15 degrees. Now 15 degrees is not one of our common angles that are found on the unit circle, so we have to split it up somehow. So the way that I'm going to do it is I'm going to split up 15 degrees, or rewrite it as the cosine of 45 degrees minus 30 degrees. So let's pretend that 45 degrees is alpha and 30 degrees is beta. So if I look at my table, the sum and difference identities, this cosine looks like this difference right here. So what we need to do is we need to expand this and write it like this. So let's do that right now. So following the difference identities, this becomes cosine of 45 degrees is cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. So let's go back and compare it. Compare this with this. There it is, we expand it. So now we're going to evaluate because we know these values. So the cosine of 45 degrees is square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2 plus sine of 45 degrees is square root of 2 over 2, and the sine of 30 degrees is 1 over 2. So now all we have to do is simplify this expression. So the first term gives me square root of 6 over 4 plus the second term is going to be square root of 2 over 4. Now we simplify that. That would be square root of 6 plus square root of 2 over 4. And that is the cosine of 15 degrees, the exact value. Let's try another example, but this time in radians. So the 5 pi over 12, that's not a common angle. So what I'll do is I'll split it up. Let's split it up like this. 3 pi over 12 plus 2 pi over 12. That is the same as 5 pi over 12. Now I'm going to reduce. 3 pi over 12 is pi over 4, and 2 pi over 12 is pi over 6. Hence, that is the same as 5 pi over 12. So let me rewrite it. So sine of pi over 4 plus pi over 6. So let's name this one alpha, this one beta. If I look at my table of identities, this is a sum, so I look for it, and it turns out that it's this one. So I need to expand it as sine alpha times cosine beta plus cosine alpha sine beta. So it has a little pattern: sine, cosine, cosine, sine. So let's do that. So sine of pi over 4 cosine of pi over 6 plus cosine of pi over 4 times sine of pi over 6. There, we expanded it. So now let's evaluate. The sine of pi over 4 is square root of 2 over 2. The cosine of pi over 6, square root of 3 over 2, plus the cosine of pi over 4 is square root of 2 over 2, and the sine of pi over 6 is 1 over 2. So now we simplify it. This will give me square root of 6 over 4 plus square root of 2 over 4. And combining these two fractions as 1, we have square root of 6 plus square root of 2 over 4. So let's do one more. This time we're going to use tangent. And what I want to do is do the same thing. Split up the 11 pi over 12 as two common angles. So how about we write it as 8 pi over 12 plus 3 pi over 12. If I reduce that, we get 2 pi over 3 plus pi over 4. So now let's rewrite it. So tangent of 2 pi over 3 plus pi over 4. So this is a sum. So let's look at our table. So now we're going to look at this one. So I want to write it just like that. This one will be my alpha and my beta. So following the table, we're going to rewrite it just like this. So tangent of 2 pi over 3 plus tangent of pi over 4. All of that divided by 1 minus tangent of 2 pi over 3 times the tangent of pi over 4. So once it's written in that form, we want to evaluate. So the tangent of 2 pi over 3 is going to be negative square root of 3. And that's because we are in quadrant 2. And tangent is negative there. Plus, the tangent of pi over 4 is 1. Divided by 1 minus the tangent of 2 pi over 3. It's going to be negative square root of 3. I'm going to put parentheses because there's a negative there. And then times the tangent of pi over 4, which is 1. So now all we have to do is simplify. So in the numerator, there's really nothing we can do. It's just negative square root of 3 plus 1. And in the denominator, we're going to have 1 plus square root of 3. And that's how I want you to leave it. That's it. So now what we want to do is we want to find the exact value of each by rewriting as a single trigonometric expression. So let's get started with number 4. Let's look at this. Notice that now we have tangent. So if I look at my identities, this one looks like the difference. Notice it looks the same. So we're going to have to rewrite it in this form now. For example, let's say that this is alpha and this is beta. And according to the identity, it's going to be tangent of alpha. Alpha is 78 degrees minus beta. Beta is 18 degrees. So now we're going to simplify. 78 minus 18 gives me 60. Tangent of 60 degrees. So now all we have to do is evaluate that. what is the tangent of 60 degrees, and that is the square root of 3. We're going to do the same thing with this one. Notice that we have a plus, so it's going to be, well, we don't know. Let's check. Which one is it? It is it? Okay, let's go on to number 5. Let's look at what we have now. So we have cosine, cosine, plus sine, sine. So if I look at my identities, it looks like this one, cosine, cosine, plus sine, sine. So let's say that this is alpha, this is beta, so this is alpha, and this is beta. So according to our identity, I have to write it as cosine of alpha minus beta. So it'll look like this. Cosine of alpha, alpha is 5 pi over 12, minus beta, which is pi over 4. So the next step is to simplify inside the parentheses, but we need the same denominator, so I'm going to change pi over 4. So cosine of 5 pi over 12 minus, now pi over 4 is the same thing as 3 pi over 12. So let's subtract. That will be cosine of 2 pi over 12. Let's reduce even more. That will be cosine of pi over 6. And now all I have to do is evaluate cosine of pi over 6. Cosine of pi over 6 is the square root of 3 over 2. The last example for today is we need to verify the following cofunction identity. So what we want to do is we want to make sure that the left side equals the right side. So what I'll do with this left side is we're going to expand it by using a sum or difference identity. Now, if this is alpha and this is beta, and we have a minus sign in between, let's look at the identities. So it's cosine alpha minus beta. That means I have to rewrite it like this. Cosine, cosine, sine, sine. There's a plus sign in the middle. So let's do that. So we'll start with the left side. So it'll be cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. Now, the cosine of pi over 2 is 0, and I'm going to multiply it with cosine x, plus the sine of pi over 2 is 1, and I'm going to multiply it by sine x. And simplifying, this gives me 0, and this is just sine of x, which equals sine of x.